Hey, I'm Lucas, the CEO and one of the co-founders here at vCluster Labs. Today, I have a really exciting announcement to share with you. It is part of our Launch Series 2025, which started a couple of weeks ago with the announcement of vCluster private nodes. I'll recap in a second what that means. Today, we're announcing auto nodes, which builds on top of private nodes. And the third announcement to come in October is called vCluster Standalone, so stay tuned for that one. Most of you are probably familiar with vCluster as the tool for Kubernetes multi-tenancy. It's become a go-to tool for folks who want to share a Kubernetes cluster. So you take a shared host cluster, and if you have a team A and a team B, and you want to give these two tenants access to the cluster, yes, you could provision a namespace. You could also give them separate clusters, but namespaces are often very limited, and separate clusters are often very expensive, not just in terms of compute, but also in terms of management effort. So we built vCluster. With vCluster, what you can do is you can spin up a vCluster pod, which is an entire Kubernetes cluster in a single pod. And now you can give this pod to one of your tenants, and they talk to that Kubernetes API server instead of the actual underlying host cluster's API server. The nodes are generally shared when two vClusters run in the same cluster. So you may end up with nodes that run containers from tenant A and from tenant B. If you want more isolation on the node level, not just on the control plane level, you can add our new product vNode. We launched it in April this year. It's a very exciting tool that essentially sandboxes containers from the same virtual cluster into what we call a virtual node. This prevents a lot of noisy neighbor issues and prevents container breakouts. Additionally, you can use dedicated nodes via node selectors in vCluster. That's a feature that's also available today. So you can essentially say, vCluster A is using this particular node, and vCluster B is using this particular node pool, and that means none of the containers from different virtual clusters end up on the same node. They're all completely separate. That's great. But what about another level of isolation? What about CNI, CSI? Pretty much the cluster is still shared here. The nodes are separate, the control plane is separate, but what about the rest? Well, if you want additional security and additional isolation, you can use private nodes. What private nodes allows you to do is still run the vCluster control plane in a shared host cluster, but the nodes get directly joined into each vCluster. That means they're private to that vCluster. And two different tenants effectively form two entirely separate clusters. Not just the nodes are separate, the CNI, the CSI, everything is completely isolated from each other. What we're adding with today's announcement is called vCluster Autonodes. What vCluster Autonodes does, it bakes Karpenter directly into vCluster. Karpenter is a great open source project started by AWS. EKS Auto Mode, as well as automatic on-demand node provisioning in AKS, are both built on top of Karpenter. Today, we bring vCluster to the same standard and add Karpenter directly inside vCluster. And that's great because it doesn't just work in a single cloud. It works in any environment, public cloud, private cloud, even in hybrid scenarios. So you can launch two vClusters with 0 nodes on the same host cluster, and they're not configured to use any of the nodes of the host cluster either. Now you launch any workload in vCluster A or vCluster B here, and what Karpenter does, it creates a so-called node claim. So it means I need a specific type of node in order to run this workload. vCluster platform will see this node claim and will try to fulfill it based on the node pools you specify for that particular vCluster. What vCluster platform does, it communicates with your node manager, which can be either your cloud provider like AWS, GCP, or Azure, or it connects with your bare metal systems such as Metal as a Service or OpenStack or any other private cloud system that you're running in your own data centers. And then vCluster platform provisions the node, which means pixie booting it or creating a VM in a public cloud, and then it joins that node as a private node into your vCluster on demand, on the fly. What makes Autonodes special is that it comes with its own concept of a node provider. By default, we're using Terraform and OpenTofu as the core node providers. That means anything you can provision with Terraform or OpenTofu can be provisioned with Autonodes, whether that is an EC2 instance, a VM in GCP or Azure, or a machine in your favorite local or niche cloud provider. Pretty much anything that you can provision with Terraform, including supplemental things such as VPNs and load balancers, can be provisioned with Autonodes. On top of that, you can obviously write your own OpenTofu or Terraform provider and use them with Autonodes. This also works for Terraform Enterprise, by the way. But it doesn't stop there. For bare metal environments, we also added an integration directly into NVIDIA BCM, which allows you to use NVIDIA's DGX supercomputers, such as the NVIDIA DGX SuperPod, for example, natively with Autonodes and rebalance GPU nodes between your tenants. As another exciting feature, we also added a direct KubeVirt integration, which means that you can provide a bunch of bare metal machines to us, run KubeVirt on top of that, and hook that into auto nodes. That means we will create right-sized virtual machines directly on your bare metal nodes using KubeVirt and KVM. This is obviously super helpful in private clouds. To add auto nodes to your vCluster, you just enable private nodes in your vCluster YAML, and then you specify dynamic auto nodes, and you tell us which providers to use. So let's say in this case, we're using GCP and 2 instances from GCP. We're using a couple of AWS EC2 instances, and on top of that, we're pulling machines from our OpenStack private cloud. That's pretty awesome. Karpenter will now dynamically decide what the right mix of machines is and will optimize continuously to make sure you're creating the most efficient vCluster possible. This is how it looks in the UI. You're defining these node providers. I have AWS EC2 here, Azure VMs. I also have NVIDIA DGX set up. You can create additional node providers here. For example, using our KubeVirt getting started guide, you could add GCP over here, or you could add any custom Terraform, BCM, or KubeVirt provider directly from over here. Let's take a look at one of these node providers. The EC2 one, for example, has different instance types defined at the bottom here, T3 small, T3 medium, etc. You can obviously change the definition of these instance types, specify how much CPU and memory they have, etc. But don't worry, all of this is configurable as code via YAML, and the underlying Terraform is stored into a Git repository over here. So if you want to use our quick start guides, you can either copy paste and specify Terraform inline, or you can fork one of our Git repositories and essentially get started from there. How does it look with virtual clusters? Once you're creating a virtual cluster, it will automatically create node claims. You can go into the virtual cluster and see these node claims over here. We are seeing that there's one node claim here for a specific amount of CPU. And then if we're going into the cluster and run a command like kubectl get nodes, which effectively is shown in this UI here, we're seeing that a specific instance is provisioned here from AWS in this case, because that must have been the cheapest instance we could join into this vCluster with this specification. How is this configured? Well, pretty straightforward. In your vCluster YAML, as I mentioned, you can see here private nodes is enabled, and under auto nodes, we're seeing that the AWS provider is currently configured. We're seeing that here in the graphical interface as well. If we were to add another node provider, I'm just clicking here, adding the Azure VMs to this, giving this a name. And now I can also specify any kind of constraints. So for example, I might say I want it in a specific region, and it shows me at the bottom already, 4 of the node types are actually located in this region and are available here. So I can preview them and can see, okay, this would be the cost for these node types. Obviously, unlimited nodes are available because Azure is going to, let you create as many VMs as you need. But if you were to use your private cloud, you could tell us, or we would actually, talk to OpenStack or BCM and figure out how many of these nodes would actually be available in your environment. That's great. If we hit save now, we're using AWS and Azure nodes rather than just AWS. Under the hood, vCluster also configures the network to create a secure VPN amongst your nodes and the control plane. So this really works in hybrid scenarios, on bare metal, in public clouds, and pretty much any private clouds and environments as well. All right, I hope you enjoyed this quick intro to auto nodes. If you're interested in this feature and want to learn more, we're going to host a webinar pretty soon. You can head to vcluster.com, and I'm going to post the link in the comments as well. If you want to sign up for that, there's going to be a bunch of Q&A and also a bunch of more detailed demos around auto nodes. Join us on YouTube, LinkedIn, or wherever you like to join streams. Thank you.